Here we have a SAT math question. Okay, let's go with the information. There is a figure given over here. In the figure above, arc SBT is 1/4 of a circle with center capital R and radius 6. If the length plus width of a rectangle ABCR is 8, then the perimeter of the shaded region is. So in the given figure, we have to find the perimeter of the shaded region. That is a part which I marked in red color. Okay, my idea to solve the problem is, first let me get the perimeter of the complete figure, that is this part. So once I get the perimeter of the complete figure, I will subtract the width of the rectangle and the length of the rectangle from the perimeter of the complete figure. Then I'll be getting the length of the part that I'm marking now in red color. That is from this point A to point C. So once I get the length of the part which I marked in red color, I can add the length of the line segment AC to the part which I marked in red color to get the perimeter of the shaded region. Actually, this AC is the diagonal of the rectangle. Usually we have two diagonals for a rectangle, and AC is one of the diagonals, and the other diagonal of this rectangle ABCR is RB. Actually, RB represents the radius of the circle. We know the radius of the circle, it's 6. So the length of the diagonal RB of this rectangle is 6. In any rectangle, both the diagonals will be equal in length. Whatever length we have for the diagonal RB, the same length we have for the diagonal AC as well. Okay, now once I get the length of the part from A to C, so I can add the length of the diagonal AC to the part from A to C to get the perimeter of the shaded region. Okay, my first step is to get the perimeter of the complete figure. For that, first let me get the length of the arc SBT. So that is 1/4 of the circumference of the circle, because the question clearly says arc SBT is 1/4 of a circle. 1/4 means 1/4 of the circle. Okay, now let me get the length of arc SBT. Let me write the stuff over here. Length of arc SBT equals to 1/4 of the circumference of the circle. That is 1/4 times the formula to find circumference of a circle is 2 pi r. So 2 goes into 2 one times and 2 goes into 4 2 times. Then I'm getting 1/2 times pi times. Okay, here this r represents the radius of the circle. It is given in the question itself, that is 6. So we can plug in 6 for this r over here. 2 goes into 2 one times, 2 goes into 6 3 times. Now when I multiply 1 and pi times is 3 pi. Okay, now I got the length of the arc SBT. To get the perimeter of the complete figure, I have to add the length of this line segment RS and the length of this line segment RT. Actually, both RS and RT represent the radius. So the length of the line segment RS is 6 and the length of the line segment RT is also 6. Okay, now let me write the stuff over here. Perimeter of the complete figure. Let me write it over here. So to get the perimeter of the complete figure, we have to add the length of this line segment, the length of this line segment to the length of arc SBT. Already we got the length of the arc SBT, that is 3 pi. Now let me add the length of this line segment, that is 6, and we have to add the length of this line segment, that is also 6, because both of them represent the radius of the circle. Now the perimeter of the complete figure is equal to 3 pi positive 12 when I combine this 6 and 6. Okay, now I got the perimeter of the complete figure. Okay, now what I'm going to do is, I'm going to subtract the width of the rectangle and the length of the rectangle from the perimeter of the complete figure. So when I do subtraction of the width of the rectangle and the length of the rectangle from the perimeter of the complete figure, I'll be getting the perimeter of the part which I'm marking in green color now. Let me do it. That is from A to C I'll be getting. So do we know the width and length of the rectangle? Actually, we have an information about it. That is the length plus width of the rectangle ABCR is 8. So we have the sum of the width and length of the rectangle, that is 8. So I'm going to subtract that 8 from this the perimeter of the complete figure. Okay, let me do it. So 3 pi positive 12 negative the sum of the length and width of the rectangle, that is 8. So when I do so, I'm getting 3 pi positive 4 when I combine positive 12 and negative 8. So this 3 pi positive 4 represents the length of the part that I marked in green color over here from point A to point C over here. So to get the perimeter of the shaded region, I need to add the length of the line segment AC. As we have discussed already, this is one of the diagonals of the rectangle. So there is another diagonal, that is RB. Actually, this diagonal RB also represents the radius of the circle. Since the radius of the circle is 6, the length of the diagonal RB is 6. So in any rectangle, both the diagonals will be equal in length. So since the length of one of the diagonals RB is 6, the length of the other diagonal, this AC, is also 6. Okay, now to get the perimeter of the shaded region, we have to add this 6 to this result. Okay, let me do it. So 3 pi positive 4, positive 6, 3 pi positive 10. So the perimeter of the shaded region is 3 pi positive 10. We find this 3 pi positive 10 in answer choice C. The correct answer choice for this question is C.